Alright, chapter 7, problem 31. We have 2 kilo body, we have a variable force on it, we have initial velocity of 8 meters per second at the 3 meter mark. The question is, part A, what is the velocity of the body at x equals 4 meters? Alright, so we're going to go with k final minus k initial is the work done on the body. Alright, so delta K is the mechanical work done on the body. The mechanical work in this case is given by this integral. This is of f of x dx. Alright, so this is equation 7-32, I think. So W equals int from 3 meters to 4 meters of minus 6x dx. Now, in the end, the units on this are going to be joules. We've got newtons in there, and since the force is in newtons, the 6 must have a unit of 1 over meters. So we're not going to worry about units until the end here. So integral of x dx is 1/2 x squared. So this is minus 6 times 1/2 x squared, right? Evaluated from 3 meters to 4 meters. Okay, so that's minus 6 at the 4 meter mark. It's 4 squared is 16 squared is 8. 6 times 4 squared is 16 times divided by 2 is 8, minus 3 squared is 9 divided by 2 is 4.5. So the work done on this is 6 times 8 minus 4.5. 6 times 8 minus 4.5 is, okay, minus 21 joules of work have been done on this. Now we know K initial is 1/2 m V initial squared, right? So 1/2 times the 2 kilos times the initial velocity of 8.0 meters per second squared. So that's going to come out to just 64 joules. That leaves us with K final is going to be 64 joules minus 21 joules is going to be 43 joules. K final is 1/2 of 2 kilograms times the V final squared equals the 43 joules. Well, the 1/2 and the 2 cancel out, and we're left with K final equals the square root of the 43, and this is going to be meters per sec. Oh no, it's going to be joules. All right, K final. Pardon me. V final is square root of 43 meters per second. Right? Square root of 43 is 6.6. So V final is 6.6 meters per second. Okay, that's it. What is the velocity at the body at the 4 meter mark? Right? And so this is the velocity at the body at the 4 meter mark. Okay. Now, part B. Part B is, at what positive value of x will the body have a velocity of 5 meters per second? Alright, part B, we're working the problem just the other way around. We start with, we have a new K final. K final is now 1/2 of the mass, 2 kilograms, times, and we want 5 meters per second. squared. So K final is going to be 25 joules. We know K initial, right, is 64 joules. That's where we started out with to begin with. So that means our work we need to do, it needs to be 25 joules minus 64 joules is minus 39 joules. That's the total work that needs to be done, is minus 39 joules. Well, from this equation up here, all right, from the work equation up here, that means in the general sense with an unknown location, we know that the work is minus 6 times 1/2 x final squared minus 1/2 of 3 squared. All right, so we can simplify this down to minus 3 x final squared x final squared plus 3 plus minus 6 times a minus 1/2 is a plus 3 plus 27 joules. Okay, and all of this needs to equal the minus 39 joules. All right, if we just solve for x, minus 3 x final squared equals minus 59 minus 66 joules. Divide by minus 3, we get x final equals the square root 22 joules. And working all the units out, this is going to end up being in meters. Okay, square root of 22 meters. Square root of 22 gives us 4.69 or 4.7 meters. All right, so x final is 4.7 meters. Now, if you're a purist, you'll note this is a plus or minus, and this is a plus or minus. And what does that mean? Well, what that means is, all right, we start off, we got an object going this way, and the force on it is that direction. So it slowly comes to a stop and heads back the other way. Now, once it passes the 0 mark, the force is actually back this way, and so it'll go out this way a certain distance and head back. And so it's going to hit a velocity of 5 meters per second once on this side and once on this side, and then it's going to hit a velocity of minus 5 meters per second on each side. So the final position, the position where it does that, is plus or minus 4.7 meters. And that's it for problem 31.